Okay, hello everyone. This is the David. Uh, for this video, I am going to tell you about the exponential and logarithmic functions, specifically exponential function. This is the first part, or call it what first part for grade 10. Actually, it's not only for grade 10; it may work for different grades for grade 12 as well as grade 11. So let's start the lesson. Exponents. What is exponents refers to over here? We know that exponents. Okay, exponents can be written as a number. Let's say a the power of let's say a the power of n is equal to, let's say, b. A is called the base and n is called the exponent, whereas b is the product. So for this lesson we are going to see what is exponents means, or what is the word exponential functions mean. If n is a positive integer, then a the power of n, okay, a the power of n is the product of n factors of a. This means a the power of n is equivalent to a times a times a times a times a. Okay, we need to multiply a how many times? N times, because the exponent is n, and the base is the number that we are going to multiply is a. So from this we know that a the power of n, so this from this a is the base, it's called what the base, and n is the exponent. That means we need to multiply, or how many times we should multiply the number a refers to what the exponent. For example, let's say, for example, to the power of 8. For example, to the power of 8 means we need to multiply 2 how many times? 8 times. So this means equivalent to 2 times 2 times 2 times 2 times 2 times 2 times 2. So finally it is equivalent to 256, right? To the 256, because this is equivalent to, we know that to the power of 4, or you can say that to the power of 4 times to the power of 4 is equivalent to the power of 8, which means 16 times 16 is 256. That means to the power of 8 is equivalent to how much? 256. So in this context we are going to see to the power of 8 means, or 2 is the base and 8 the exponent. This is the way to solve. Let's see the example, the practical example to evaluate it. Okay, to evaluate that means as we know that this can be it says what? Evaluate. For the first example, evaluate negative to the power of 6. Negative to the power of 6. This means we need to multiply the number negative 2 how many times? 6 times. Don't forget that since the exponent is even, we need to multiply this base how many times? 6 times. And we know that a negative number times a negative number is positive. So to expand these numbers, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, how many times? 1 2 3 4 5, and we left 1 times negative 2 is equivalent. This means if we say that this, the first 2 becomes what? 4, and the second 2 becomes what again? 4, and the last 2 becomes what? 4. This means 4 times 4 times 4, which is equivalent to 64. Look, since the exponent is even number, we need to the product of even number of negative is always positive. That means negative 2 times negative 2 times negative 2 times negative 2 becomes, because when we pair it there is no an extra negative number, so the final becomes what's a positive number for this one. But we have to consider over here, this means it can be written as negative 1 times 3 the power of 4. Don't forget over here the base is 3, the exponent is 4, it does not contain the number negative. Okay, this negative can be written as negative 1 times 3 to the power of 4. So this can be written as negative 1 times 3 times 3 times 3 times 3. We need to multiply 4 times. So this can be written as, finally this is 81, and this is negative 1. This can be written as minus 1 times 81, which is negative 81. Look, the difference between the first A and the second one, this one B. For the first one, the base is negative 2, but the second one is, the base is only 3. You have to take care of this. For C, this means our base is a negative number, and the exponent is odd, so the final answer must be what? A negative number, because when we pair all the numbers, we left a single number like this: negative 3 times negative 3 times negative 3 times negative 3 times negative 3. Look, the first when we pair, we left finally 1. This can be written as what? This is 9 times 9 times minus 3, which is minus 81. 81 times minus 3, which is equivalent to negative 243. This means negative 3 the power of 5 is equivalent to negative 243. The reason why this number becomes negative is the exponent is so much odd. That's good. Odd. For the last one, to see the last one, this can be written as negative 3 times 4 square. Look, this square, this exponent is only for what? The base 4, but we have to multiply negative 3 finally. Okay, we have to remember the rule base mass, which means first bracket, then exponent, then division, then multiplication, then addition, finally subtraction. So first we have to remove the exponent. That means 4 to the power of 2 times minus 3. This means this is equivalent to negative 3 times 16, which is equivalent to negative 48. Okay, it becomes what? Negative 48. This is how can we find the exponents, or how can we find out the powers, or the powers. In this context, you can say that the easiest method of solving exponents. Now let's move to the other statements. We have to apply the laws. For example, let's say, how can we solve the number to the power of 3 times 3 to the power of 3? This means without multiplying directly. This can be written as 2 times 3 the whole the power of 3. This you needs what? A power, or we call it what? Instead of laws, we can say it again one property. This can be written as properties. We can say that properties ማለት እንችላለን ማለት ነው። So if the bases A, B are a non-zero real numbers, non-zero, which means positive, it may be what? Positive, or it may be negative, but it must be what? Different from zeros. Numbers, and the exponents, okay, the exponents m and n are integers. Okay, integers, whatever it is, negative, positive, or zero, the exponents must be what? Integers. Then these rules must be what? Always what? True. Okay, always true. So from this you can see that this means a to the power of m times a to the power of n is equivalent to, since we have the same base, we can add only the exponents. For example, let's say if we say that 2 to the power of 3 times 2 to the power of 2, yes, 2 to the power of 2, this means 2 times 2, the first 3 times 2 times 2. So we have 5 2's, right? This can be written as 2 to the power of 5, which means, or in short, we can write about 2 to the power of 3 plus 2, which is equivalent to the power of 5. This is the property of exponents. If we have the same basis and a different exponents, just we can, during multiplication of these numbers, we can add only the exponents. On the context of division, a to the power of m over divided by a to the power of n can be written as a the power of m over a the power of n. Since we have the same base, okay, be careful over here, the bases must be what, the same or similar. Then we can subtract the exponents, meaning subtract the second exponent from what, from the first one, okay, from the first. For example, let me say 3 the power of 5 divided by 3 the power of 2. For example, this can be written as, we need to multiply 3 how many times first? 5 times. Let's say 3 times 3 times 3 times 3 times 3 divided by 3 times 3. Since we have 2 3's from the numerator part, the denominator part, this can be simplified, this can be simplified, so we left only 3 3's. This means 3 is the power of 3, or we can say that this can be 3 is the power of 5 minus 2, which is 3 is the power of 3. We can write this like this. These are the way of solving the same basis but different exponents. Okay. The other one is if a the power of m the whole the power of n can be written as, and this means we need to multiply a the power of m how many times? N times. This means we need to multiply a the power of m time how many times? N times. This means a the power of m times n. We can multiply only the exponents. This means mn. For example, let's say if we say to the power of 3 the whole the power of 2 means, this means to the power of 3 times to the power of 3. This can be, we need to multiply to the power of 3, which means this is our base to the power of 3 itself, and the external exponent is 2, so we can write just like this. It can be written as to the power of 3 plus 3 by using this rule. Okay, this rule, so this can be written as to the power of 6, or in short this means 3 times 2 is 6, simply to the power of this 6. This is another way of the properties of exponents. Okay, exponents. If we multiply different numbers with the same exponent, which means, for example, let's say 2 times 3 the power of let's say 3, this can be written as, okay, individual product. Okay, the individual exponent, which means to the power of 3 times 3 is the power of 3. This is equivalent to 8 times 27. Okay, 8 times 27, this can be written as 16 226, right? 8 times 7 56, we left 5. 5 times, so this becomes what, 216, sorry, to say it 226, it becomes what, 216. This is the way how we multiply the two numbers inside the bracket with a common exponent, or just we can multiply the two numbers with each exponent after we distribute it. The other one is, don't forget over here, b and a are different from zeros or non-zero numbers. This can be written as a over b the whole the power of n can be written as a the power of n over b the power of n. This means, for example, let's say if we say 3 is the power of 3 over to the power of 3, or with the same exponent, can be written as 3 over 2 the whole the power of 3. The same is true, by the way, in this all the properties, the vice versa equation works. Okay, the vice versa equation works always. This can be written as 27 over 8. 27 over 8. So it's a kind of property always. The other one, which is the sixth part, a the power of 0 is equal to 1 if a is other than 0. Actually, we said already a and b are different from zeros, so a number the power of 0 is equivalent to 1. How this could become is 1. For example, let me say in easy way, 100 over 100 is equivalent to 1. We know this rule. A number divided by itself is always 1. So this can be written as 100 means we know that 10 square, right, over 10 square. From the property of division of numbers, okay, division of numbers with the same base from this Roman number 2 can be written as 10 to the power of 2 minus 2, since we have the same base. By the way, in this context, if the base are different, don't subtract the exponents, okay, because the bases are different. In order to subtract the exponents, the base must be the same. So this can be written as 10 to the power of 0. We know that 100 over 100 is 1, so this works for what? 0. In general we can say that, or a to the power of n over a to the power of n. This means we know that a is any real number other than 0 and n is any integer. This can be written as, okay, a to the power of n minus n. Okay, a to the power of n over a to the power of n is equal to, which is 1, right? So n minus n is a to the power of 0. This is equivalent to 1 always, okay, always. This becomes what? But a should be different from 0. The other property, the other law says what? A to the power of minus 1 is equivalent to 1 over a. 1 over a. This could be becomes what? If we say, for example, let's say minus 1 means, let's say a to the power of 0 minus 1, right? It's possible. This can be written as a to the power of 0 over a to the power of 1, which means a to the power of 0 is, we got it what? 1. This can be written as 1 over a to the power of 1 is itself the number. So what that is, where a is different from 0. A is different from 0. So the 7th property and the 8th property are similar. The only difference is the first one is minus 1, but this one is minus n. So the same is true for n is greater than 0 and a is different from 0. This also works what? For this one, yes, for this one we know that this can be written as a to the power of 0 minus n, as we have seen before. This can be written as a to the power of 0 over a to the power of n. We know that a is other than different from 0, n is positive integer, so this can be written as a to the power of 0 is 1 over a to the power of n. So a to the power of minus 1 minus n can be equivalent to 1 over a to the power of n. For this one, it's the reciprocal statement, okay, reciprocal statement, because as we know that a to the power of minus n is equivalent to 1 over a to the power of n. So this is equivalent to the same is true for if a over b the whole the power of minus n can be written as 1 over a over b a the power of n. This means we know that 1 over a the power of n over b the power of n. Okay, this can be written as b the power of n over a the power of n. So from property 5, this is equivalent to b over a the whole the power of n, the whole the power of n. It can be written as just like this. So this is the laws regarding these exponents. Okay, we have to remember this one, since if it is if we don't know the laws, some questions may be difficult to solve, simplify. Okay, let me see the examples to simplify. Okay, to simplify. Okay, let me change the ink. Okay, let me make it this one. Okay, this is this means we know that 4x the whole the power of 2 times 4x the whole the power of 3 in the bracket. Okay, inside the bracket we have 4x as a base. Over here 4x as the base, since we know that a to the power of m times a to the power of n is a to the power of m plus n. So from this we can say that 4x, okay, 4x the power of 2 plus 3, because we have the same basis. This means 4x the whole power of 5, because 2 plus 3 is how much? 5. So this can be simplified just like this. These statements to simplify, the number 16 and the number 8 are not the same as the base, since 16 is the power of 1. So 16 we can reduce all those two bases into a single base or a similar base in order to simplify it. This means 16 is, we know that, to the power of 4. To the power of 4 is 16 times 8 means 2 cube, right? 2 cube the whole power of 3x. This means we know that to the power of 4 times to the power of from the property of the product of the bases with different exponents outside the exponent, it can be written as to the power of 3 times 3x is 9x. And again we have the same basis, which is equivalent to the power of 4 plus 9x. 4 plus 9x. This is the basis becomes what? 2, and this becomes what? 9x. 9x. So this is the way to simplify this for C. Since whatever the number inside the bracket except 0, okay, if it is except all kind of all real numbers except 0, the power of 0 is, we know that a the power of 0 is equal to 1 if a is different from 0. A is different from 0. This, so from this 35 the whole the power of 1 over 2 at the power of 0. This can be written as 35, okay, the power of, this means 1 over 2 times 0 is 0. A number the power of 0 is how much? 1. Therefore the radical 35 the power of 0 is how much? This becomes what? 1. Since the degree or the exponent is negative and the number the base is fraction, so we can reciproc this fraction the base and change the negative exponent to the positive exponent. This can be written as 3 over 2, okay, the power of how much? 4. Since the first base is 2 over 3 and the degree the exponent is negative, so we can reciproc the base again, make it what? The exponent is positive. This means 3 is the power of 4, okay, over 2 the power of 4. This 3 the power of 4 is 81 over, okay, 81, and 2 the power of 4 is 16. So the final answer is 81 over 16. 81 over 16. Okay, for the E part, E for the power of 3m over 8 the power of m. Since to make it to subtract the exponents we have different bases. In this context it's difficult to subtract because the bases are completely different, but if it is possible to change it to the same base, we can change it. The number 4 and the number 8 can be changed into what? Base 2. So this means 2 square the power of 3m over 2 the power of 3 the whole power of what? M. This means 2 the power of 2 times 3m is 6m over to the power of 3m. So this is equivalent to, since we have the similar base, we can take the number the base 2 and the exponents becomes what? 6m minus 3m, which means we are subtracting what? The exponents, okay, exponents. 6m minus 3m is to the power of 3m, okay, we can see that to the power of 3m. So this is the simplest form of what? For the power of 3m over 8 the power of m. This can be in easy way similar to the df, which means since the exponent is negative and the base is fraction, we can reciproc the fraction first, which means 7 over 4, okay, 7 over 4, and the power of what? Make the negative number what? Positive, the power of 1. And number the power of 1 is itself, so it becomes what? 7 over 4. Yes, it becomes what? 7 over 4. This is the way to solve. G for G part. G for G. This means 16 the power of 3x minus 4 over 16 the power of 3x minus 4. Now we have the same value of exponents, which means we use the same base with the same exponent, which means like a the power of m over a the power of m type. Okay, so this is equivalent to 1, or in short, or we can say that we can make it 16 the power of 3x minus 4, okay, minus 3x minus 4 from the base, from the lower part, okay. We have to take it from the lower part. This means 16 the power of 3x minus 3x minus 4 plus 4, because 3x minus 3x is like minus 4 minus is plus, becomes what, plus. So this becomes what, 0. This also becomes 0. 0 minus 0 is 0. So this becomes what, 16 the power of 0. A number the power of 0 is 1. Okay, 1. Or in other words, the same base, the same exponent, okay, when you divide it, it becomes what, 1. Again, for h, 64 the power of a times 4 the power of a. This is how we change the same base, or we can say that the same exponent but different bases. Since we can write this number like 64 times 4, okay, the power of what, a, which means splitting. This one is splitted power product, but we can mix it, or we can collect, since we have the same exponent. 64 times 4 is let's say 4 times 4 is 16, carry 1. 4 times 6 is 24, plus 1 is 25, okay, 25, and the power of what, a. So this means 256 the power of a. This is the simplified form. Okay, for I, the exponent 3 is the exponent of all the numbers inside the bracket. Therefore, the number 2 for the number a, as well as for b square. So this key is to the power of 3 times a the power of 3 times b square the power of 3. This means 2 cube is how much? 8, and a cube b the power of 2 times 3. Okay, this becomes what, in this context you have to multiply it, otherwise you will make a mistake. 2 times 3 is b the power of 6. Our final answer is 8 a cube b the power of 6. This is the way to solve. For j part, we have 2 negative exponents. Okay, we have 2 negative exponents. We can do in different ways. The first one, since the number 1 is a number itself, so a number, the power of any number is the number itself 1, so we can write this one 1. This means 1 over 4, okay, the power of minus 3. We can express the inner one, okay, the inner one just like this. Again, the whole the power of what, minus 1. This is this can be written as, since the base are the base is this number, or first we can multiply this the 2 exponents. This means 1 over 4, yes, the power of minus 3 times minus 1. Minus times minus 1 is positive, so it becomes what, 1 over 4 the power of 3. This means 1 cube over 4 cube. Okay, this is 1 cube is 1 itself, over 4 cube is 64. Final answer is 1 over 64. 1 over 64. This one is actually, this is the same as, since the number, the exponent is the outer exponent is negative, we can make it what, we can make it, this one is 1 reciprocal. This means 1 over 3 z square, yes, sorry, make it the power of what, 3, and make it the exponents positive, since we reciproc the bases. So this can be written as 1 cube over 3 cube times z to the power of what, 6. Okay, because the z square should be what multiplied 3 times. So this means we know that 1 cube is 1 itself. Okay, 1 over 3 cube is 27. This is to make it difference, let me make it z, the power of what, power of 6. So, or we can say that this can be transformed over, or z the power of minus 6 over 27. It's possible to write just like this. Z is the power of minus 6 over 27. Okay, this is the way to solve exponential functions. Okay, exponential functions. Okay, the other one is actually the rational exponent. This is similar with or the same as we have seen before. The only difference from previous one is the exponents are rational. Previously we have seen the exponents are integers. The exponents are integers, but for this context, our exponent is rational. We know that rational number can be written as we know q can be written as a over b form, where b and a are any integers other than 0, right? Where b is different from 0, because the denominator never be 0. This is the way to solve. So for if a is greater than 0, which means a should be what, positive real number, and n is an integer with n greater than 1. Okay, if n is 1, it becomes what, the number itself 1. Therefore a the power of 1 over n is equivalent to the nth root of a. Don't forget over here the number inside the radical should be always positive, unless if we didn't determine the value of n. So this will be works if a is negative and n is odd. For example, let me show you. The cube root of negative 27 is negative 3. Look, our index is odd and the number inside the radical is negative. In this case, it's possible. But if we say that radical, the fourth root of minus 16, this is not belongs to what, real number. This is not belongs to real number, because there is no any real number that gives negative after we multiply even number times. Okay, even number of times. So in this context, this is not a real number. In this context, this number should be positive real number. Okay, positive real number. Okay, so from this, let we see additional informations. If a greater than 0 is positive real number, and m and n are integers with n is greater than 0, greater than 1, sorry, a the power of m over n, a the power of fraction, okay, can be written as a the power of m the whole power of 1 over n. Previously we have seen, in this case we can multiply m and 1 over n, or we can write what, the n is root of a the power of m, or just simply the n is root of a the whole the power of m is possible. All the four statements are the same way, the same expressions with rational exponent. For example, express the following as a the power of m over n, and says what, simplify if it is possible. If it is possible, simplify, otherwise you have to express what, a the power of m over n type. So from a, this the index is 4, which means it can be written as 5 the power of 1 over 4, because our n value is 4 over here. Since the number 5 is a prime number, this is difficult to decompose, so we have to write what, 5 the power of 1 over 4. This can be written as 64 the power of 1 over 5. Since the number 64 is a composite number and it can be expressed as a prime exponent, so this can be written as 64 means to the power of 6, okay, and the whole power of 1 over 5, 1 over 5. So from this this can be written as to the power of 6 times 1 over 5 is 6 over 5. To express this statement is just like the 4 types, okay, there's 4 types. It can be written as the fifth root of s to the power of 6, or you can say that the fifth root of 2 the whole the power of 6. It can be written as just like this. Okay, this can be written as again 1 over the radical 9. Radical 9 is the number that's number 9 is perfect square number. This can be written as 1 over 3. Okay, this is the simplest form. Or this we can write what 1 over 9 the power of 1 over 2, since the radical implies what power of fraction numbers. So this can be written as 1 over 9 the whole the power of 1 over 2. 1 over 2, this means square root of 1 over 9. Okay, 1 over 9. So this is equivalent to 1 over 3. The same is true for as we have did before. For this value, this one means the third root of 32 the whole the power of 2. This means 32 the power of, okay, 2 over 3, because m is 2 and n is 3. So m over n can be written as to the power of over, this means 4 the power of 5 over 3. So this means since our denominator is 3, so we can write just like this one, 32